need to create dynamic data endpoints, where the content changes based on client-provided parameters, like city names or repository paths. You'll see how FastMCP's resource templates let you define flexible URI patterns with placeholders that map directly to function parameters. We'll build endpoints that respond with weather data for any city or repository info for any GitHub project, all while keeping the implementation clean and type-safe. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals data server. Hash template URI includes city placeholder. At MCP resource, weather/city/current. Def get weather city SDR dict provides weather information for a specific city. Hash in a real implementation. This would call a weather API. Hash here, we're using simplified logic for example purposes. Return. City capitalize. Temperature, 22. Condition, sunny. Unit, Celsius. Hash template with multiple parameters and annotations. At MCP, resource. Repos, //owner/repo/info. Annotations equals. Read-only hint, true. Idempotent hint, true. Def get repo info owner, SDR repo, SDR dict. Retrieves information about a GitHub repository. Hash in a real implementation. This would call the GitHub API. Return. Owner. Name, repo. Full name, fowner/repo. Stars, 120. Forks, 48. This demonstrates the URI template pattern for creating parameterized resource endpoints. The concept transforms static resource definitions into dynamic, parameter-driven data access points using URI placeholders like city or owner/repo. What makes this distinctive is how it bridges the gap between declarative URI routing and imperative function logic, enabling REST-like parameterization without manual root parsing. The pattern works by treating URIs as templates where placeholders map directly to function parameters. When a client requests a templated URI, FastMCP extracts the parameters, injects them into the decorated function, and returns the result as a resource. This creates a clean separation. The URI template defines the contract, while the function contains the implementation, with no manual parameter extraction or validation code required. This approach solves the problem of exposing structured, parameterized data without writing repetitive root handlers. It's particularly valuable for APIs, data services, or AI tools where clients need to fetch variations of the same resource type, e.g., weather for different cities, repo info for different projects. The trade-off is that URI templates must align exactly with function signatures, but this constraint ensures consistency between the exposed contract and the underlying logic. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI callable tools. It transforms Python functions into network-accessible resources that AI models or other services can invoke directly. MCP equals FastMCP. Name equals data server. This initializes the FastMCP server instance named data server. This central object registers all AI callable resources and handles incoming requests, acting as the core router between AI models and your Python functions. Hash template URI includes city placeholder. At MCP resource, weather/city/current. This defines a URI template with a dynamic city parameter, creating a resource endpoint that FastMCP exposes to AI models. The placeholder enables a single function to handle requests for any city, eliminating the need for separate endpoints per location. This is the standard pattern for parameterized resource paths in FastMCP.
Def getWeatherCity SDR dict.
This defines the weather function with type hints that FastMCP converts into a tool schema. The city SDR parameter becomes a required string input, while the dict return annotation documents the structured output format for AI callers. Type hints here serve double duty: Python type checking and AI tool interface definition.
Provides weather information for a specific city.
This docstring defines the tool's purpose and behavior for AI models. It becomes part of the tool's schema, enabling proper discovery and usage by AI systems.
Hash in a real implementation. This would call a weather API. Hash here, we're using simplified logic for example purposes. Return.
This returns mock weather data for demonstration. In production, you'd replace this with an actual API call to a weather service, but the simplified response maintains the same schema the AI expects. The placeholder implementation lets you test the tool interface without external dependencies.
City capitalize.
This normalizes the city name by capitalizing the first letter, ensuring consistent formatting in responses regardless of input case. Handles user input variations like New York or London while maintaining clean output formatting.
Temperature 22.
This hardcodes a default temperature value for demonstration. In production, this would be replaced with actual API data, but here it ensures the function always returns a complete response structure regardless of implementation status.
Condition sunny.
This defines the current weather condition as a static string. In a real implementation, this would be populated by an API call, but here it demonstrates the expected response structure for weather data.
Unit Celsius.
This specifies the temperature unit in the response payload. Standardizing units prevents ambiguity in API consumers, ensuring consistent interpretation of numeric values. This closing brace terminates the dictionary definition, finalizing the structured response that will be returned to the caller. It ensures the function returns a complete, well-formed data object that matches the declared return type hint.
Hash template with multiple parameters and annotations. @MCP resource.
This demonstrates FastMCP's resource template pattern with extended configuration. The decorator accepts both a URI template with multiple path parameters and optional metadata annotations, enabling richer tool definitions while maintaining clean function signatures.
Repos //owner/repo/info.
This defines a URI template with two path parameters, owner and repo. The curly brace syntax, param, creates dynamic segments that FastMCP extracts from incoming requests, passing them as function arguments. This pattern enables clean, res-tful resource addressing while maintaining type safety through the function signature.
Annotations equals.
The annotations dictionary attaches metadata to the resource endpoint. FastMCP uses these hints to optimize tool usage, like indicating read-only operations or idempotent behavior to prevent duplicate processing.
Read-only hint, true.
This annotation marks the resource as read-only, signaling to clients that this endpoint won't modify server state. Critical for API safety, it prevents accidental write operations and helps clients optimize caching strategies.
Idempotent hint, true.
This flag marks the operation as idempotent, meaning repeated identical calls produce the same result as a single call. FastMCP uses this hint to optimize caching and retry logic, ensuring safe retries without unintended side effects. Critical for GET operations where call duplication shouldn't alter system state. This closing brace terminates the dictionary literal, completing the mock API response structure. It ensures valid Python syntax and maintains consistent return types for both resource endpoints. Closing parenthesis for the getRepoInfo decorator call terminates the resource definition, finalizing both the URI template and annotations before the function implementation.
Def getRepoInfo owner, SDR repo, SDR dict.
This function signature defines an AI callable tool with two required string parameters. The type hints and parameter names automatically become part of the tool's schema, enabling FastMCP to validate inputs and generate documentation. This pattern ensures consistent, self-describing interfaces between Python and AI systems.
Retrieves information about a GitHub repository.
This docstring defines the tool's purpose for AI models and documentation. It becomes part of the tool's schema, ensuring clear usage context when exposed through FastMCP's interface.
Hash in a real implementation. This would call the GitHub API. Return.
This placeholder comment marks where you'd implement the actual API call in production. The hard-coded return demonstrates the expected response structure, ensuring the function signature and return type match what callers expect. This pattern lets you develop and test the interface before implementing the real backend logic.
Owner.
This maps the function parameter directly to the response dictionary, preserving the original owner value. It's a straightforward pass-through that maintains data integrity between the input and output, ensuring the API response matches the requested resource.
Name, repo.
This maps the repository name from the URI template parameter to the response payload. Maintains consistency between the requested resource and return data, ensuring clients receive the exact repository identifier they queried.
Full name, fowner/repo.
This constructs the repository's full name by combining owner and repo with a slash. Standard pattern for GitHub-style repository identifiers, ensuring consistent formatting regardless of input variations.
Stars, 120.
This hardcodes a star count of 120 for the mock repository response. In a real implementation, this would be populated by the GitHub API call, but here it demonstrates the expected response structure for AI tool consumers.
Forks, 48.
This hard-coded forks 48 value simulates repository metadata in the mock response. In production, this would come from the GitHub API, but here it demonstrates the expected response structure for AI tool consumers. Closing brace terminates the dictionary literal, completing the function's return value. This ensures the function returns a properly structured response that matches the declared return type hint. URI template pattern. FastMCP's RFC 6570 URI templates transform static Python functions into dynamic resource endpoints, where the URI structure itself becomes part of the function signature. Wildcard parameters capture everything until they hit another defined segment or literal. making them greedy by design. The template system lets you expose a single function through infinite URI variations without changing the underlying code.
The URI that never changes handles every possible path.